example 3s here just to give us a little more practice doing the kind of factorial algebra. And right away, it's important to remember what the combination formula is. N choose R is n factorial over n minus R factorial times R factorial. And really most of this question is just trying to manipulate and simplify what these look like. I do want to write one of these kind of aside. N choose 5 typically students don't struggle with. Let me write that first. N choose 5 is n factorial over n minus 5 factorial times 5 factorial. The one on the bottom is a little bit tricky because it has an expression instead of just an n. And what n minus 1 choose 3 is going to be n minus 1 factorial because that's taking the place of the n, right? These are really in the same place in that formula. And then on the bottom, what I'm going to have is in a bracket n minus 1 minus 3 factorial and then multiplied by 3 factorial. Now I'm going to clean that up a little bit, and I'm going to say that that is n minus 1 factorial over n minus 4 factorial times 3 factorial. And it's one of those things that we have to get a little bit used to, that they can put expressions in place for n or r and then still expect you to be able to manipulate that. Now, in the simplification of this, that entire, what I'm asterixing there, it needs to go into the denominator. So all of that is divided by n minus 1 factorial over n minus 4 factorial times 3 factorial. And the first thing that I'm going to do is, instead of dividing by a fraction like that, I'm going to write the fraction in the numerator multiplied by the reciprocal of the fraction in the denominator. And that's a process that we do a ton in math, so hopefully you're pretty comfortable with that. I do want to reiterate what we did in the permutation section, was that if you have a variable factorial, it's the variable times 1 less than that, times 1 less than that, until eventually we get 3 times 2 times 1. And we typically don't know how far to go until we get 3 times 2 times 1. And the reason I bring that up is essentially we can make or rewrite factorials as smaller expressions, but not larger expressions. And what I mean by that is I can rewrite n factorial to contain n minus 1 factorial. But I can't rewrite n minus 1 factorial to contain n factorial because n is larger than n minus 1. So what I'm going to do in this question is I'm going to look to rewrite my factorials so that I have identical factorials in the numerator and denominator, and then we can start to cancel. So n factorial is going to become n times n minus 1. And now because there's an n minus 1 in the denominator, I'm going to stop there and throw my factorial piece in. N minus 4 factorial is going to become n minus 4 times 1 less, which is n minus 5. And again, because of this n minus 5 factorial, that's where I want to stop. I want that n minus 5 factorial to be there. The 3 factorial is almost an afterthought. It still needs to be there. The denominator, I'm going to write them together. We're going to have the n minus 1 factorial, the n minus 5 factorial, and the 5 factorial. But 5 factorial, I'm going to rewrite as 5 times 4 times 3. And because we have the 3 factorial in the numerator, I'm going to throw my exclamation mark at that point. And now what we see happening is, because the numerator and the denominator are just a bunch of factors, everything's multiplied together, the n minus 1 factorial cancels with the n minus 1 factorial. The n minus 5 factorial cancels with this n minus 5 factorial, and the 3 factorial cancels with that 3 factorial. And so what I'm left with, and this is kind of the final simplified version, although I'll show a little bit of more simplification we can do, we have n times n minus 4 divided by 5 times 4, which is 20. Or we could write that as n squared minus 4n divided by 20, just by distributing that n on. Now, this takes a ton of practice. This is effectively kind of, brand new math that we just talked about in chapter 11. And certainly chapter 11, this is part of why it's more difficult. But most students learn to kind of love the factorials because they're really practicable. Right, you can keep doing factorial questions until you're sick of them, which you might be already, and you will get better at manipulating this type of algebraic expression. Whereas, choosing whether it's a permutation or a combination and dealing with some of those restrictions is not as practicable, I would argue. Still, you should do questions in the textbook and you'll get better at it. But definitely you can just kind of grind out this factorial algebra. Permutations and combinations require a bit more deeper understanding sometimes. All right, that being said, there's one more that we have to do, and it looks like a bit of a doozy, but we're going to take it piece by piece. So the 2 is multiplied out front. N choose 2 becomes n factorial over n minus 2 factorial times 2 factorial, and this is equal to, I'm going to write it up here again, that n choose r is n factorial over n minus r factorial times r factorial. So n plus 1, choose 3, is going to be n plus 1 factorial. Let me write that factorial a little bit better. N plus 1 factorial divided by, in a bracket, n plus 1 minus 3 factorial times 3 factorial. And basically all we're doing here is anywhere we see n, right here and right here, I am replacing them with the n plus 1 expression from the question. All right, we're going to clean this up a little bit because it's going to do us a pretty big favor. I'm going to write this as 2 times n factorial over n minus 2 factorial. 2 factorial is 2. And so we are going to cancel those in a minute. On the right-hand side, there's not much I can do here, but I am going to write it as n plus 1 factorial divided by n plus 1 minus 3 is n minus 2 factorial. And then I'm going to change 3 factorial. 3 factorial is 6. Now, we need to solve this as if it were any other type of algebra expression. And that's, we're going to try to isolate the variable. To isolate the variable, we have to get it out of the factorial notation. And in order to do that, we are going to write large factorials as their kind of smaller counterparts within the same fraction. But before we do anything, 2 divided by 2 is 1. So we're going to get rid of that 2 immediately. And then I'm going to rewrite n factorial as n times n minus 1 times n minus 2. And I'm going to stop there because we have an n minus 2 factorial in the denominator on the left-hand side. For the right-hand side, this is a little bit trickier. N plus 1 factorial becomes n plus 1 times n minus 1 times n minus 2. And I could keep going, n minus 3, minus 4, and so on. But again, n minus 2 is in that denominator. So I'm going to put my factorial in place at that point. And all of that is divided by n minus 2 factorial times 6. All right, there's more cancellations we can make, certainly by design. We very, very intentionally manipulated it this way. So the n minus 2 factorial is going to cancel on the right-hand side. And the n minus 2 factorial is going to cancel on the left-hand side. Now, I'm going to multiply that 6 over. I'm going to write the next line as 6 times n minus 1 is equal to n plus 1 times n minus 1. Now, if I want to isolate my n variable, there's nothing wrong with dividing. So I'm going to divide both sides by n and n minus 1. And the reason I want to do that is I notice that those factors are common on both sides. So the n's will cancel, the n minus 1's will cancel. That's actually going to happen on both sides. And then what I'm left with is that 6 is equal to n plus 1. Well, if I subtract 1, I get that 5 is equal to n. Now, before we get too happy that we solved this right, just remember that 5 is equal to n. We're going to go back up, and I'm actually just going to drag it down so we can do it beside what I just wrote. I really do think it is beneficial for you to check your answers, right? Understanding that because we're solving an equation, we can verify. We can take our solution for n and plug it back into, and I can't emphasize this enough, the original equation. So I want to check if 2 times 5 choose 2 is equal to 5 plus 1 choose 3. Well, this is 2 times 5 choose 2 is equal to 6 choose 3. We're going to evaluate those kind of, piece by piece. So if I do 5, let's go over my math menu. So 5 choose 2, I get 2 times 10, and 6 choose 3. I think we probably know what it needs to be, but it is 20. I get that 20 is equal to 20. This is good. Now, something I talked about a little earlier is if you have NPR, n must be greater than or equal to r. And n must be a nice natural number. So no decimals, no negatives. For n choose r, those restrictions are the same. We get that n must be greater than or equal to r, and we also get that n is an element of the natural number system. Now, if we look at this question, because it's n choose 2, I know that n must be greater than or equal to 2. And then because we have n plus 1 choose 3, I know that n plus 1 must be greater than or equal to 3. So n must be greater than or equal to 2. So this is our restriction. We knew that we couldn't get a number less than 2. We solved it algebraically, and that's what we want to get you to do in most times. But it is important to understand that as soon as we involve some math operations, and this has happened throughout the course, it brings with some restrictions on the variable, which we can exploit to kind of, maybe hem in our answers so we're not looking at every possible number out there. All right, the assignment is on here. This is definitely one of those important assignments to practice and chip away at the questions. please email me if you are struggling. I will help you. We'll get through this digital stuff, and hopefully we can be in the classroom again next year.